Hello. My name is Cristina Elizondo, and my presentation is foaming soap. And this is like my 10th time that I'm presenting. I don't know, I'm having a hard time with my computer. You don't want to, the sound is, I don't know, just can't hear my voice. You can see me presenting, but you cannot hear my voice. So I'm hoping that through here I can submit it. I'm already tired as it is, presenting all over. Okay, but this is my presentation, and it's about the foaming soap. And my hypothesis is which soap will make the most foam, the Ivory or the Dial. For Ivory, I chose the Dove. And I'm going to keep it as short as possible because I have a limited time on my cell phone and on my computer. So, excuse my time. Okay, so my materials are one bar of Ivory soap, which is the Dove, 1 bar of Dial soap, the Dial, paper plates, microwave, and the knife, and of course the measuring tape. And what I did was my procedures were measure both soaps, length, width, and height, and record the measurements of each. I calculated the volume by multiplying the length, width, and height together. I cut the bars into 4 equal pieces, but I put 2, and I placed both of I first started with the Dove, so I placed both in the paper plates. Then it says right there like to try it for 2 minutes, but I minimized it to 1 minute and 10 seconds because I got this odd smell from the microwave and I didn't want it to burn, so it was a strong smell of the soap as it is. And after that I removed, and I did the same thing for the Ivory. For the Ivory soap, before the microwave, the length was 4 inches, the height was 2 inches, width was 4 inches, and the total was 18 inches. For the Dial was 3 inches, 3.4 inches for height, 1.8 for width, and the total was 18.36. Then that was before I actually microwaved the whole situation of the soaps. And my first soap was the Dove, which expanded really well because due to the air molecules, so it pretty much did good, and also chemical reaction, which happens right here. And for the Dial, it wasn't as much. It was all right here clustered. Looks like a Rice Krispie. But what I also figured, I tested it on the water and it floats, so it's like kind of like plastic. So it's pretty dense. And what I also found out about this is that it's just a quick little information of the Ivory soap that I have here in my word. The Ivory soap is one of the few brands of bar soap that floats in water, and I just tested that because it's true. But when you break the bar of soap into several pieces, there are no large pockets of air inside, which explains why it's weightless. Oh, sorry, excuse that. And there are no large pockets. If it floats in water and has no air pockets of air, it must mean that the soap itself is less dense than water. Ivory soap floats because it has air pumped into it during the manufacturing process. So also what I found out, a quick little information, was that this was accidentally discovered by a worker, that this Ivory soap floats by leaving it while he was on a lunch break. Why does it expand in the microwave? And this one, it was the Dove. It's very similar to what happens when popcorn pops or when you try to microwave a marshmallow. Those air bubbles in the soap or the marshmallows contain water. Water is also caught up in the matrix of the soap itself. The expanding effect is caused when the water is caused by the heated microwave. The water vaporizes, forming bubbles, and the heat causes trapped air to expand. Likewise, the heat causes the soap itself to soften and become pliable. This effect is actually a demonstration of Charles' law. Charles' law states that as the temperature of gas increases, so does its volume. When the soap is heated, the molecules of air in the soap move quickly, causing them to move far away from each other. This causes the soap to puff up and expand to the normal size. The Dove soap. Other brand of soap without whipped air tend to heat up and melt in the microwave. In other words, the Dove soap has more air molecules, so that's why it expanded in size. And the length after that was 5 inches, height 6 inches, width 4 inches. With the Ivory, it expanded the most. The Dio stayed kind of like in the same. The length was 3 inches, height was 3 inches, width was 2 inches, and volume 18 inches. So it stayed on the same small size. Other than that, it was a very good experiment that I even managed to test deeper because I found out that the Ivory can float, and the Dove actually expands more in size and it becomes hard after. But there was a chemical reaction. I saw the bubbles float, and that was a very good. I enjoyed my experiment and figuring this whole new situation. And again, I have to keep my presentation short. Excuse my short. It's just that I'm running out of time. I have other homework to do as well. I don't know if it's not part of it, but I don't know where else to go to. I'm trying everything I can and to submit this video. I'm already frustrated, but I managed to do my whole experiment. And yes, thank you for listening to my experiment. I would like to make it bigger, but I'm limited in time and space for my computer. Thank you. Oh, my dependent variables were the heat, because on both they expand. Well, actually it expands on the Dove, so that's my dependent variable, the heat. And for the Dio, it's not as much. Well, it's heat, but it just, instead of expanding, it clustered. They became together. And on the other one, it expands. Thank you.